we're gonna do proposition 1.44 today, and this is kind of a long one, so hopefully I can get this done in 15 minutes and leave Dan some time. So proposition 44, the statement is very simple. It says that to apply a parallelogram to the same with the same area as a given triangle, and to a straight line with a specified angle. So what I'm going to do, I'm going to try to do the construction on the diagram on this board, and then prove that the construction does give us what we want. So what this means, to apply a parallelogram with the same area is essentially to construct a parallelogram with one side the same as a straight line that's given at a certain angle that's also given. So this is what it means to apply a parallelogram. So the construction is going to be somewhat complicated. So I'm gonna I'm gonna just note here, right? So the given straight line is going to be called AB. I'll do this in the diagram in a bit. And the specified angle, I'm going to follow kind of modern convention and use Greek letter theta to do it, to denote it. And the given triangle, I'm gonna leave denoted for now, and I'll indicate on the diagram where this triangle is going to be. So AB is going to be a line segment. I'm going to actually draw this line AB, and I'm going to draw AB and actually extend it out because I'm going to need this line to be longer. What's the exclamation mark in the line icon there? You
It's
guys
a
added a new
new
feature.
it's a new pen that JPack added, yeah. So if you draw with that, it's like the pen in GoodNotes if you've used it that disappears after you draw. So if you draw, you use it to draw an arrow or something to draw attention to something on the board, and
Oh
then
wow!
without erasing, it'll go away.
Very cool. Very cool. Very cool. So I don't know whether I have any use for it right now, but maybe I'll work it in at some point. Okay, so we have this line AB, which is marked on the diagram like so, and we're gonna actually construct this triangle that's given to us with side BY, right? So this is something that's not quite done in this way in Euclid. You know, in Euclid, there's maybe some magic about moving triangles around. We're actually going to construct it using proposition 22, as Dan indicated to me in the message, that this is one way of getting a triangle where we want it. So I'm gonna I'm gonna get this triangle here. I'm gonna just construct it in red. We're not actually gonna need this triangle, but I'll have it there just so that it's kind of clear what we're doing. So this is the triangle that's given, and we'll call this BFY. Okay, so I'm gonna just say I'm gonna say BFY here. Right. So the first step here, the first step, this is going to be a little bit different from what we've done before. I'm going to be denoting a lot of my steps in blue on the diagram because it's kind of hard to follow if it's just one wall of text. So it's going to be kind of in the diagram. So I'm going to use proposition 22, right, to construct triangle BYF. And this is a triangle, given three sides, we can always construct it on a given line segment BY, well, on a line B, right, such that BY is one of the sides. So I'm going to use proposition 22 to do this. And then, and what we're going to do now is we're going to use proposition 42 to construct a parallelogram BEFG such that this parallelogram has the same area as this triangle. And so following kind of the construction in proposition 42, we take the midpoint here, right? And we kind of did this thing, see if I can get it right. Um, we constructed a parallelogram with a specified angle, so I'm going to do this as well. So, oh, that's not a straight line. Sorry, I was hoping this will be
Just to be
okay.
clear, I'm
Let's
following.
try again.
So you're you're saying here that even if you're given a triangle out in space somewhere that's different from this line,
Mhm.
your first step is to read off its lengths, feed them into proposition 22, and reassemble it in a place that's more convenient for you. Right?
Yeah, that's correct. Yeah,
Cool.
cool. And so, what we're going to do here, we're going to construct a parallelogram. I'm going to try and get this right. Well, actually, that's going to be fine because well, this is going to be, it's going to be some kind of parallelogram. Um, I'm going to just see if these points all line up. Almost good enough. All right, so we're gonna construct step two here. Is step two here. We're gonna use proposition 42 to construct a parallelogram. In the parallelogram, I haven't labeled it yet, but I'll label it now. BFG. Hmm. Did I call F? Well, I'm gonna relabel my point F here. This is not meant to be F. I was careful to use different letters in my notes. BFZ. Use letters from the end of the alphabet so I don't collide with F, but I failed. There we go. Right. So this parallelogram, to construct a parallelogram BEFG, um, with angle, I guess BEG equals theta, and area equals BFZ. There we go. And so I'll also label the angle theta
Do you
here.
really mean
Well,
BEG?
probably. Oh, B
BEF? Or
F.
like,
Yeah, yeah, yeah. Oh, EBG. Sorry,
yeah, that
I'm
makes more
getting
sense.
mixed up with my letters. Sorry, man. EBG. I'm gonna blame writing small.
You did say it was a complicated construction. That was your out.
Yeah, there are a lot of lines. It's not really complicated. It's just complicated because I'm stupid.
I'll snip that part from the recording. That's good.
All right. Well, I mean, it's fine by me if you leave it in.
Oh, I
So,
did.
right.
I
So
didn't
this is
mean
a
to cut it
parallelogram.
out. I meant that I would highlight it and share it on its
Oh.
own.
Oh, that's hilarious. All right. So let's draw this here. All right. So what's the next step? So we constructed a parallelogram, right, with the same, with as the same areas as the red triangle. So step three is we're gonna be using. We're gonna be. What are we doing? Step three is we're going to be constructing a. Sorry, my notes are completely. I'm just going to draw in some lines and see what the next step should be. So I'm going to extend this parallel line, which we need to do. And I'm also going to extend this parallel line, which we need to do. And of course, the next step is to construct a parallel line at, um, oh, A. Sorry, yeah, A. We have to construct a parallel line at A that's parallel to these two lines that I've just extended. So okay, that makes sense. So we're gonna use one of the previous propositions. I'll tell you which one in a minute to construct this line here. So step three is to use proposition 31, I think, to construct line through A, parallel to those two, GB or FE. They're both parallel, so it doesn't matter which one. And we're gonna call the line of intersection, point of intersection of A, well, this line A through A, and FG by H. So that's what we're doing. And right, so that's this one. So step 4 is that we're gonna extend this. We're gonna extend this diagonal from HB, right? I'm gonna do it like this. So HB. I'm gonna extend it through, and
I didn't
the
notice this
claim
earlier,
here,
but
which
I think there's another typo. The area of the parallelogram you constructed should be equal to BYZ, or
oh yeah, I guess yes. Thanks. BYZ. D here and down here as well. I did the mistake twice, didn't I?
suspicious.
BYZ. Okay, cool. There we go. And so back to where we were up to, we're actually just going to call this point K. And I have to justify why HB meets FE. So I'll do that on the next board. There's probably not enough space here. So step 4, which I'll come back to, is HB and FE meet meet at K when extended. Okay, so basically the claim is that these two lines are not parallel, and we can do this extension thing, and they'll meet at K, and we're going to use this point K. The last thing we're going to do is to draw a parallel line through K parallel to HG or AB. All right, so I won't make a point about this. I'll just do it because we've already done this before in step 3. So we're going to do that. And I guess it's okay that it cuts through the writing. It's not too bad. And so this is parallel. I'll do 2 arrows here, right? And so I'll label some points, M here and L. Okay, so that's the construction. It's a bit complicated, lots of lines. I mean, we just had to make sure everything fits and all the commentary fit. And so I have to justify point 4, why HB and FE meet at K. And once we've got that, this construction makes sense. So, the claim of 4 is that HB meets FE right at K, right? So the proof is that HFE and AHF, right? So these are the two internal angles of the line HF, internal angles of HF falling on parallel lines, right? And the parallel lines are FE and HA and HA. Okay, so they sum to 2 right angles, right? And this is proposition, I forgot what it was, one of them. I guess I didn't write it down. Dan, if you know what it is, maybe you can tell me.
I think it's proposition 30. No,
Leave
I
that.
also forgot 29. Yeah,
29. Thanks. Okay, so the angles. So now we're gonna look at the angles HFE and BHG sum to less than. My pen's failing. 2 right angles. Right, so by postulate 5, they meet. Okay, so basically HFE is one of the angles in one of the corners, and AHF is the other one on the other side, and BHG is actually a part of AHF, right? So the sum of these two have to be less than two right angles, and therefore they're gonna meet lines not parallel. So finally, the claim of the actual proposition is that A, B, M, L, that's the parallelogram we constructed with this kind of cascading construction with these parallelograms. On the right hand side of AB is a parallelogram. With AB as one of its sides. Okay, we don't have to prove this. This is just a given. And ABM equal to theta. All right, so this we have to make one comment about, whose area is equal to B. I guess it's BZY. It's wrong in my notes. I guess that's why it's wrong when I write it. Okay, so what we're gonna do, we're gonna start with the top left-hand parallelogram, HLK. Oh no, sorry. HLKF is a big parallelogram. If you go back to the previous diagram, HLKF is the parallelogram that the biggest one that gets cut into four smaller parallelograms. So that's the big one. So this is a parallelogram. So it's a parallelogram because opposite sides are parallel by construction. Parallel by construction. And the parallelograms BEFG and ABML. So these are the ones that are on. I guess they're the complements of the diagonal BK. To use the terminology from last time, they're basically, if you look at the diagram, is a top right and a top left and a bottom right parallelograms. So these are equal, right, from proposition 43 last week. So the parallelograms BEFG and ABML are complements about the diagonal HK. The diagonal HK. So next board, I guess now I have to walk. Oh, we all have to walk. Oh, I just have to walk. Okay. Okay. So where was I? So by proposition 43, they're equal. So by proposition 43, they have equal areas, I should say. They have equal areas. And these have the same. Oh, hang on. Let me fix my handwriting. Have the same area as triangle BZY. So that's because BZY was constructed to have the same area as HLKF. Okay. So this is basically step one. So finally, by proposition 15, does that say 15? Yes, I hope it says 15. The angle GBE is equal to ABM, and this is equal to theta by, I guess we just declared it to be the theta angle that we wanted. So that's it, right? We've shown that the area is what we wanted, one of the angles is what we wanted, and of course, one of the sides, AB, is constructed to be, AB. So that's it. That's how we construct a parallelogram with those parameters.
Nice.
So is it just your drawing that makes theta look like 90 degrees?
Yes.
Okay.
Yes, my drawing is not the best. Theta is whatever angle. It can be kind of really acute, and then my drawing will be flat on its side, and I kind of wanted some space.
I guess one thing that's worth pointing out is the the difference between proposition 42 and 44 because they're similar looking, right? 42
Mm,
says to construct in a given angle a parallelogram equal to a given triangle. And if you look at the proof, you can also put the parallelogram on one of the sides of the triangle. You pick one. Um,
yeah.
that's not emphasized in the statement, but in proposition 44, it's emphasizing that to a given straight line. But as you said at the beginning, Ken, you really, the parallelogram is constrained in the first place to be on that line and to have it as one of its sides. Is that
Mm,
right? That,
yeah, I think so. Yeah. At
yeah,
least that's how I interpret to apply,
right.
because that's what he did, right? In the end.
That's right. Yeah. Yeah, that was good. I had flagged when I read the proof this "let it be placed" line. Uh,
Mm.
what did you do that didn't seem to appear in what you said? What was so
Oh, I guess
Euclid
I
says
just kind of took I just took your suggestion to use proposition 22 to construct the
right,
triangle with some given side lengths, right? And
right,
in some sense, that requires us to be able to. Well, we've been doing it all along, right? We measure side lengths and we produce on another line with that length. So we're able to transport side lengths
right.
from one place to another. I guess, just because we have a measuring instrument, maybe. And so if we're able to measure one side of the triangle by, then we have like, I'm just thinking about the construction, right? You just have these compass constructions to make the triangle appear there, right? So I think that's okay.
Yeah, yeah. We're touching on a topic we've hit a few times, which is what operations are allowed and how do you think about them. So Euclid talks about moving triangles around, but what we anytime he does that, at least so far, what we can actually just read it as is reconstruct the damn thing wherever you
Yeah.
moving it to. It's not necessary to have uh, an operation which picks up a figure and slides it around continuously. That's not something you sort of imagine doing. It's not
Yeah,
like you cut
I
these
guess
out of
we
paper and then
certainly
read it.
can't do that, because otherwise, why are we proving these propositions about constructing parallelograms with one given side? We're allowed to slide things around. We can just slide it
Right,
there, right? But so
right.
I guess implicitly we're not allowed to do that. So when he says, "Oh, just kind of place it on that side," I think you are right to call BS on it and say, "Well, how are you doing that?" Right? You know, you you're just saying there's a triangle there. Well, but yeah, 22 allows us to put the triangle there, I guess.
It's interesting that clearly Euclid knows which things are allowed and
Yeah,
which aren't. It's just a matter of
yeah.
language that makes it confusing. But cool. Yeah, we don't have time for the next proposition, so I escaped this week. But I guess we'll do this.
Cool. Yeah, this was
it's
pretty
it's
long
it's pretty
actually.
quick. Yeah,
When I was preparing, I'm like, wow, this is kind of longer than all the other ones I've done. Yeah.
yeah. This is a non-trivial thing. Proposition 45 is pretty straightforward. It's kind of half. The second half is just a repetition of the first half. So I reckon we can
Oh, I
get
see.
two done next week, and then Pythagoras the week after that.
Yeah, Pythagoras.
Cool. Thanks, everyone.
Cool. Cheers.
All right. Well, yeah. Let's give some applause.
Is there an action
Did you?
I can do besides yawn?
Yeah. Just type GG in the chat, and you'll clap.
Oh, but then I'll be applauding too, right? I'll be like
Oh yeah.
applauding
Oh,
myself.
oh well. That's all right.
I'll find a backflip animation.
Yeah. Oh, backflip, right? You're applauding
Or like
Euclid.
take a bow,
You're looking at the
or
board.
maybe I don't know.
Yeah.
Yeah.
Yeah.